moving further, we can also create a detailed report in this drawing, in this analysis result. We can create print preview of individual parameters, and we can also create a detailed report. We can just also uh, click on static structure and just take the review of this figure also, that whatever parameters we have placed, we can also just take this also and click on print preview. And if we want to generate a report of all these parameters, a detailed report, after the print preview option, we can see here report preview. Just click on this option and Ansys will automatically create a report, a detailed report, whatever is being done on this project. Okay. Now the most interesting part on this is that we can just send this report to directly to MS Word or PowerPoint as on we want. We can directly print the report. We can directly publish the report. We can change the font size. Just click on it, and by clicking on same button, the font size is being increased and decreased also. But we can just change this report and parameters by sending is directly clicking on send to option and then clicking on Microsoft Word option. And by sending is directly to MS Word, we can just change the parameter of this report. See, automatically MS Word window has been opened on my screen. Just I'm going to change this to print layout view, and we can see here that the report is being fully, it's of 10-page report. I've just done a very small work, and automatically Ansys had generated a 10-page report, whatever work I have done. Okay, we can easily adjust all these parameters here. Like if we want to change the date, we can change the date here. If we want to give the previous date, we can give the previous date here. Plus, we can see here that it's giving a first save, then last save, the version, save project before solution. Since we have not saved the project, so the status is coming here no, and we have still also not saved the project after solution, so it's coming here no. Then the figure on which we have done the analysis, we can see here the figure, and by default the contents or index has been also made, and this index is in the form of link, which means if we want to see the material data, just if we are placing the cursor on this material data, it's coming the message press control. If you are clicking the CTRL and just clicking on material data, we have straight away come to this page number 9 on the material data. So we don't have to make this thing. Ansys automatically by default generate all these reports. Suppose we want to see the loads, whatever we have placed, just control and click on load option, and we can see here the load. But we have to just understand about the table, that how the table and layout has been done here. Here are the contents, that is units, model, geometry, solid coordinate, mesh, static structural, material data. Now in unit session, Ansys is going to display that whatever unit we have taken, whatever unit we have worked with, we the system has been generated the unit system, and that is in metric format. Here it is mm, kg, newton, second. Angle we have taken in degrees. Rotational velocity is in radian per second. Temperature is in Celsius. Now in geometry, there is a detail of the geometry also. Our object name is geometry and the geometry is being fully defined. Now it is not necessary to give each and every details if we are making a report. Suppose we have to make a report and submit the reports towards our higher authority. So it is not necessary to print and give them each and every report. That is, we don't require to give this source file, that where we are going to save this project. It's the path giving here. It's not required. So just we can delete this option and delete the cell also. Okay. Now the type is design modeler, length unit is in meters, element is been programmably controlled, and display style is body color. Now here coming the dimension of our figure, that is length is x direction is 80 mm, y direction is 30 mm, and in z direction we have extruded in 300 mm. So we can see the details here. Whatever the report Ansys give, we just also have to know the correct form or correct method also, that how to read that report, so that if we know the method how to read the report, we can also explain to the further authority also that what the report is actually be saying. Suppose your higher authority ask for that where we can see the material data, what material you have taken. So you don't have to read the whole report. If you have studied the report, you just will be aware that material data is being placed at the last, and we can just move directly to pressing by pressing control and then clicking on the material data, and here we can see the details of the material. So when we have studied the report in details, we can make others also explain about that detail. Now so we are getting here that the dimension of the figure is here. Moreover, automatically the volume is been also calculated. Its volume is 7.2 into 2.5 mm3. Mass is also given, that if we make a dimension of this dimension of structural steel material, the body, its mass will be 5.6 kg. Now we are taking the scale factor 1. We have body 1, active bodies are 1. In this, the nodes is 1533. Now the confusion occurs in this, that if we see the figure, if we see the geometry, I have just make you aware about that. If we are setting on the node selection on, we can see here node. The node is here is 1, 2, 3, 4, 5, 6, 7, 8. Now the question arises, and if we are going to seek the job, or if we are going to write the thesis for your MTech or any other perspective, the question arises that in your figure, in your body, there are only 8 nodes: 1, 2, 3, 4, 5, 6, 7, 8. Then how comes the Ansys is giving this result that the nodes is total 1533? And the solution is that, or the answer is that, this node is not this one, but it is the meshing nodes. Means after giving the meshing, here you can see the nodes. If we select on meshing of mesh option, and in the details of the meshing, we can see a statistics option. Here we can see 1533 nodes created. Means after meshing the figure, the total nodes that are generated, the result is calculated on this node, not on the whole body figure. Okay, not on this figure. Okay, that's why the nodes is showing 1533. It's this only, the nodes are showing 1533. Same to same, the elements are 240 here. It's taking data from this. Here you can see in static structure also that there are 240 elements in it. So this data, the nodes and elements, we have the Ansys is taking from the meshing section of the geometry. Okay. Now, basic geometry option, parameters we have taken, parameter parameter key, it's DS by default. Now attributes, we have not taken any attributes, we have not taken any selections, and we have not taken any material properties. So we can skip all these values. If we want, we can just right click on it, delete cells, or then clicking on the delete entire row option, all the rows is being deleted because Ansys give you more than the appropriate result. So whatever we don't required, if we want, we can erase it or edit it. Then advanced geometry option, we can see here use associativity. The option is yes. We don't use any coordinate system, so the option is no. We don't have any reader mode. The option is no. Now, there is no smart CAD update. The temporary file, since we have not saved any files, so the temporary directory is giving here. And this is the advanced geometry option, which no one really requires to know about it. Okay. No one doesn't require that where you're saving a figure, we have created or saved your figure is or not. If you have not saved the figure where the temporary directly, but Ansys of course give you this all in this report. Now moving to further, we can see here object name solid status. You can see that we have meshed our figure. Every part has been visible. There is no suppressed. Stiffness behavior is flexible. We have used the default coordinate system, and reference temperature is whatever the environment condition is given. Plus material assignment, we have assigned the material structure steel, as I told you earlier that ANSYS works on structure steel option. So structure steel, there is non-linear effects, there is thermal strain effects. Again, it's coming and repeating the option that the dimension of the figure is given here, volume also given, mass also given, and plus some more criteria has been automatically calculated in is that is centroid. By taking this dimension, ANSYS automatically calculated the centroid of the figure, that is minus 40 in x direction, y direction 15, and in z direction the center of centroid is 150 mm. Plus moment of inertia also is being calculated about x-axis, that is IP1, it is 42814 kg meter kg mm square. Then moment of inertia about y-axis and z-axis is also automatically being calculated. Now again, node and elements are repeated here in the static structure. Coordinate system, the state will be fully defined. We have used Cartesian coordinate system, and we have taken the origin of the figure, that is xyz in 000 direction. The directional vector is also given. So this is the detail for the model. Now coming to the mesh table. Meshing plays a vital role in ANSYS, and in ANSYS project, every company, every manufacturer, or anyone for whom so ever you are going to make any of the report, any of the project, this meshing report is also very necessary. That what method you have used for meshing, how you have controlled the mesh report, how you have generated the mesh, in how many nodes, in how many sections you have divided the figure. So this all details have been shown in this mesh portion. That is object name mesh, state has been solved, physical principle is mechanical. We have not worked on the sizing, that's why it has taken the default unit. So when I will teach you about the meshing, here all the default parameters will be get changed as we have selected or as we will select in the mesh section. That is relevance sensor will be coarse, elements are default, smoothing will be medium. It's taking the default value because we have just generated the mesh, and here everything will be program control, element, mid side node sub, anything, any everything will be in program control. And here we can see again the nodes is 1533 and elements will be 240. Moving towards the static structural. In static structural, the physical type is structural, analysis type is static structural, and solver target is mechanical APDL. Now, Ansys works on two modes, that is, one is on click mode, on icon or menu mode, and one is on APDL file format mode. Now, APDL is the programming mode that study those who want to study advanced Ansys, especially those who are programmer, not a mechanical but a programmer person from CS or IT branch, they used to study mechanical APDL. And whatever I have done, whatever I have performed the process by the help of icons and clicking, for each and every step program has been written. So that portion is known as mechanical APDL. Now, all these analysis has been done by taking the environmental temperature up to 22 degree, that is ambient temperature. We can change the temperature also and perform analysis. That way I will let you know later. Now static structural, the figure is fully defined. We have just taken one step and we have just applied the force for 1 second only. We can see here that we are taking the when we are working on it, the force here on the right side tabular data, the force is applied, the 100 Newton force is applied for 1 second only, which means that for 1 second only we have applied the force on the body and then release it. And by the help of this and by taking this parameter only, the deformation is coming. So in next section, I will let you know that how to increase the time, that if you want to apply the force on the body for more than 1 second, how to increase the time also. But since we have taken the time by default 1 second, so here the step and time is showing 1 second. Okay, and everything is being programmably controlled. Okay, now here we can see here that object name state, there is a table being made that object name state force fixed support. The figure is fully defined. Now here the force is given here, that is 100 Newton, and it is ramped. And we have defined the force by giving the direction, which is we have defined the force by giving the vector. Plus, we have also given the fixed support. Now, in this geometry, I have given the force on the edge. So here it is placed one edge, and I have suppose given the fixed support on one face, so it is given here one face, which means we have support given the force on the edge and supported the fixed support the whole face. So there is one graph given regarding with the static structure and force. It is applied for only time 1 second. So here this is the time axis and here it is the magnitude axis, that is force axis, that in 1 second the force is applied, that is 100 Newton. Now in solution section we can see here that the status has been solved, and in the solver output we can see here that all the result has been calculated and tabulated. First of the result is total deformation, and the total deformation minimum is 0 mm and maximum is given here, that is 2.47. Okay, then middle principal elastic strain, here minimum value is minus 3.92 and maximum value is 3.92, and same maximum shear stress, minimum value is 1.2 and maximum value is 1.31. Now here also we can see minimum overtime value and maximum overtime value. It will be the same as the above value in case of maximum shear and principal elastic strain. Okay, the time is being given, it is 1 second. Now moving on to the material data, we can see here that the material we have taken structure steel, and by default whatever will be the structure steel of the property is given here, that the density of the structure steel, coefficient of thermal expansion, specific heat, thermal conductivity and resistivity, plus compressive ultimate strength, yield strength, tensile yield strength, tensile ultimate strength, temperature, and whatever is the cycles, plus its ductility coefficient, strength exponent, strength coefficient, ductility exponent, whatever is the value for structure steel, by default value is being taken here, and here is the details of the whole material. So you can see that we have just done a very small amount of work, that is just fix one support and just given a load on the under face, and by taking this we have just solved three parameters. Maximum parameters are programmably controlled, and Ansys give a 10-page detailed report. So whosoever do analysis, whosoever plan to do like whatever in which year the BTech students they have to create the report regarding their final year project. If they are doing MTech, pursuing PhD, everyone just use this software, especially mechanical and civil person and electrical person also, in order to generate a report, because for PhD and MTech master's process, it's not possible for everyone to make a prototype or model or working model, right? So they move towards the physical testing, and this can be done by the help of ANSYS. You just to choose some parameters regarding with centrifugal pump, internal combustion engine, anything regarding to their stream, and just work on this, use the ANSYS software, work on various parameters, just analyze and give the result, and by the help of it they can finish their report and submit the thesis, because ANSYS give you the written reports in details. Okay, so this software is beneficial for those person also. Okay, so you can just save your report here and MS Office. So I don't need this report, so I'm just now saving it. Plus, if we have done the analysis, just close this model window, and you may see in this workbench window that every parameters the tick mark has been placed, which means that this analysis, this report has been finally been done and performed. If you want, you can just click on any of the window, that is setup, solution or result, to view the results only again and again as you want. Okay, after performing the analysis, if you think that your analysis has been performed, everything has been done, you have to just save your project. But make sure that before doing any analysis work, you just save your project so that your data is not being lost. Just click on file menu and then click on save option. So Ansys will save this whole workbench. I'm just going to save this on my desktop. Its extension name is .wbpj, that is workbench project. I'm just going to save here by the name CK and just clicking on save. So this file is being saved. Just look on this. You can see here given below there is option save project. Just wait for it. When there is option coming ready, which means that their project has been saved, and you can see here on the title bar CK workbench has been written. So you have just saved this project. Okay, so this is all about the today's session.